Hi, in this video we're going to talk about security in cloud computing. First of all, let's talk about some of the advances that were made in cloud computing in the last few years. Some early examples. In the way back in 1996, you may have seen cloud computing happen with Hotmail. It was the first time you could use a web browser to check your email. Later, Salesforce provided one of the first business applications, a customer relation management program, a CRM, which allowed people to log in and do nothing except for use a web page for the business app. VMware came along in 1999 and started doing virtual machines. These are all advances that would help with cloud computing. And then in 2006, Amazon, which is now the biggest cloud player, allowed people to rent servers on their systems because they had so much capacity in their servers that were built up to handle the holiday shopping traffic. In cloud computing, there are really 5 essential cloud characteristics. First of all, a cloud service will have on-demand and self-service, kind of like a vending machine. They will also have global access, and so it costs a lot of money for a cloud company to develop because they have so many data centers around the planet. Also, a key characteristic is to have a shared resource pool. And so they build this massive data center and share it among thousands of customers. Something like you would have a library where you have a shared collection of books. So not all customers have to buy the same book. Also, dynamic growth. So you can expand your service and shrink it depending on the needs of your current processes. Now, you would also have the measured meter kind of going, so you would know kind of like a pay-as-you-go cell phone bill that lets you know how much you're going to pay based on how many users you get and how much traffic is hitting your website. So those are 5 essential services that you would find in cloud computing. So first of all, with on-demand, you would think of that you are subscribing to a server service. So you would have databases and online storage and CPUs and memory and all things that you can select from a menu, and without any kind of personal communications, you can use their control panel like in Azure and sign up for a server which is small and free to very robust and somewhat expensive. On demand. Also, resource pooling. You would have one large share of servers and resource like storage that is shared among customers. And so in this example, you can see this control panel is allowing us to create a resource pool. A resource pool can put in multiple servers in one place and share it among different applications. Also, the idea of being dynamic is that you can add resources quickly when you need to. So a startup company might not be able to afford a large server, and they might not need it. But they're hoping that in a few months, they're going to be overwhelmed with traffic. And with a cloud service, they can start with a very free and cheap system. And then as they grow, they start paying revenue on a monthly basis. So in this case, you can see that there is a metric showing a spike in demand. And so if there is some new product or something new in the news that happens to be lucky to hit your company, you don't have to go out and purchase servers that might sit idle in a future time. And so dynamic growth is a key feature of cloud computing. Of course, you're going to pay for all this. And so it's more expensive, perhaps, to run a full on-demand service, but the convenience is often worth it. And so you're going to get a bill from Microsoft Azure, and it's going to tell you how many bytes you've used and how many cycles of the CPU have been used and how much storage is currently being done. Now, universal is a key part of cloud computing because your servers don't have to be located at your business. They can be located anywhere. And so if for some reason you start picking up customers in China and India, the servers there can serve just like they would do closer to home. Also, your service is going to be available on any kind of platform, so just like you would do with any kind of web page. Now, a good way to understand the cloud service is to think about pizza as a service. So let's take a look at 4 different situations where you want to buy a pizza. So you can have mom do it at home, and she gets to do all the work. You can do a take and bake, which is taken from the store, obviously, and it's already pre-made, and a delivery, where you just have someone show up and give you the pizza, or if you want to be treated very well, you go to a restaurant. Now, there is a list of things that have to be done to create the pizza. So look at starting at the bottom. So Obviously, you need the ingredients. You need cheese and sauce and toppings and dough. And then you have to have the pan. You have to have someone assemble the pizza. You have to put it in the oven. Then you have to wash the dishes and serve it at the table. So if we were to split this up into two different segments, such as the red where you provide this and the blue is that someone else provides this. So if you make your pizza at home, you're going to have to do everything from assemble the pizza to cook it to clean up the dishes. If you want to do take and bake, obviously you're only going to have to do the oven part, wash the dishes, and serve the table. Everything else is done by the service, and so that's pretty convenient. Delivery is even a little bit better. You skip the oven part, and they put it in the oven for you, and it's delivered hot. Hopefully. And then if you go to the restaurant, of course, you get the entire experience. So when you're done, you simply add a tip and you walk away and leave all the dirty dishes for somebody else. So that's a little bit like what you would do with your computer services. So the cost obviously is higher on the right side. So you expect to pay more for a complete service restaurant. But the startup and overhead costs are actually pretty high. So if you didn't have a kitchen and you had to buy an oven just to cook a pizza, just think of the cost that would be there. So the startup and overhead costs of purchasing a home and installing a kitchen are pretty high. If you're just brand new in a startup company, the restaurant looks pretty attractive because you don't have to buy any of those expensive servers. So when we talk about cloud computing, there are really three different categories of what you would provide as service. So first of all, there is something called software as a service. We'll call it SaaS, which is kind of like the Hotmail or Gmail or Office 365. Everything's provided through a web browser, nothing to install, you just use it. Now, platform as a service is like renting a server and you install the software on it. So platform as a service has been around as long as there's been web hosting companies such as GoDaddy, and so you don't have to buy the server. And then there is a complete solution called infrastructure as a service, and that would provide you with the entire network that is virtually hosted on somebody's cloud. So there you go, three categories: SaaS, PaaS, and IaaS, we'll call it. Now let's go to the SaaS and talk about some examples there of what has been popular and what you might know. So Google Docs and Gmail, Office 365, those are all things that we've all logged into, and we understand that we only need the web browser and we have this full service. But think of Dropbox, that's a SaaS. Facebook, there's a full app on there. GitHub, really, you only have a website. And then I mentioned Salesforce earlier and Concur, which I'll show you an example of in just a second. But these are all software as a service. You just think of web browser and a login and nothing to install. Now also, here's an example of Salesforce. So Salesforce was one of the early software as a service companies. You can see that their point of Salesforce is to manage customer service, customer calls. They're trying to make sales calls. And so the salesperson just logs into the website or uses the mobile app, records who they talk to and how interested this person is and who needs to follow up with a quotation or whatever the customer needs. And so Salesforce has been selling their product and never installing it on anyone's computers for some years. Concur is another example of how you would use software as a service. So they manage travel expenses. So as you might remember, in the old days, if you went on a trip, you would collect your receipts, you would fill out a long form and tell the boss how much money you spent on the airplane, how much you spent at the restaurant, tips and whatever, and all your things were done in paperwork form. Now with the Concur, they've said, hey, let's just let you log into a website. We'll let you purchase the plane tickets and reserve the hotels, and all expenses are automatically calculated, and we get these pretty graphs. And so nobody has to install anything, and so it becomes a great service to the company that doesn't have to spend so much time and hours working on all those receipts. So Concur is a great software as a solution type of a product for businesses. Let's take a look here at platform as a service. So a platform as a service is really just trying to give somebody a virtual machine online. And so this is a setup. As you can see, the picture shows that we're using Microsoft Azure and we're creating a new server. You can see there's a list of all these different types of operating systems that we could pick from, and we can configure it with how much memory we want, how big the CPU should be, and all the different features that you would normally get. But you don't have to physically actually install the server. It's a virtual machine. And so that is a platform as a service. Also, you would think of infrastructure as a service as a bunch of virtual machines, not just virtual servers, but virtual routers, virtual firewalls, virtual databases. All these things are tied together and you get to configure them. You get to set the IP address, you get to filter the firewall, you get to connect these, you get to throttle the network, you get to let people through and others not. So you get the entire network as you want it, and you get to put it in a cloud. So it's a virtual control panel, and you would never actually have to install any wires or configure anything except through the virtual software portal. Here's a picture of a server being set up. So it's a virtual machine, and in this case, we're choosing Windows 2008, the server, and you can decide what you want to install on it. So you might be miles away from it, but you get to set it up. Now, software as a service is going to give you the advantage that you'll never have to install anything. So I know as a previous network administrator, a big deal in the old days was that we had to set up these images and deploy them through the network, and everybody's computer needed to be configured and upgraded. None of that is required if you just rent a service online. Just make sure that your web browser works, and your login is going to make it all easy. So Google is probably the best example, where they have Google Docs and Gmail and other services that come with that Google account. So Google is a great example of consumer software as a service. Platform as a service is a great way to say, I want to have a server and I don't want to have to set it up. I don't want to monitor it. I don't want to reboot it. I don't want to upgrade it. I'm just going to let the company that manages the server do all of that for me. And so you think of a startup company. Now, this looks like a pretty typical startup. They're all sitting around a desk. They're typing away. They're web developers. There's nobody in here that is the server expert. They just assume that Microsoft or Amazon is going to handle those servers for them, and they can concentrate on writing code. So that's a great idea for a startup company. Infrastructure as a service is going to allow you to have a complete network in the cloud. And there are 3 different ways you could do that. You could say, I'm going to take everything and throw it on the cloud, and so I don't have to worry about installing anything. You could also set up a private cloud. You can still keep the servers in-house and make them all virtual machines and virtualize everything. So companies that are big usually would think about private cloud as an option. Or you could have a mix. You can say, some of my servers are online at Amazon and some of them are here in my data center. And it depends on, of course, the needs and the comfort level you have with your service provider. So once again, here's a picture of somebody that's setting up a network. They have a router that's virtual. They have virtual machine servers, and they can configure how the communications are done between those servers. So that's infrastructure as a cloud. What do you get with it? So let's take a look at the continuum here from left to right. So if we wanted to say infrastructure as a service, you're getting a data center and you're getting a whole bunch of network equipment. So that would be the package that you get when you buy infrastructure as a service. Now, if you want to have like a server, you would have a platform as a service. So you can not have to purchase any of the hardware, but you can just virtually run it from a web browser. And then if you want to have the entire package where you just say, I want to buy and lease the rights to use the software, you think of the application that I need and how much does that application cost me per month. So that would be what you get with software as a service. Now, when it comes to responsibilities and security, there's a continuum here as well. So if you purchase the infrastructure as a service, you are really not getting a whole lot of service. You are having to do all of the work yourself. You install all of your operating systems, your antivirus, you configure the firewalls, you configure the routers. That is pretty much still in your ballpark. You're still in your court. Now, also, if you go to the platform as a service, then you're going to just focus in on the applications and coding those. So you're going to be a developer and you don't have to worry about running the server. If you are just going with the software as a service, you don't even need developers. You're just going to rent the service and pay the company a monthly fee for how many ever users that are logging into their service. So there's a continuum of what the customer has to do when each of these is presented. Let's talk about web hosting. So in the early days when there were these virtual servers available to you, GoDaddy was probably one of the leaders, and they still are a big company. You get one server. You set up the server and then you have to install things on it. You have to monitor that, make sure that that server is working. So you're pretty much given a machine that you don't have to touch, but it's still a machine. Now, if you go to the cloud providers, so you can see we have Azure and AWS and Google Cloud, you're going to have multiple instances. So you might not even know where your server is. Your application servers are pre-configured for you, and the growth is expanded. So if you tell Microsoft that you want to automatically grow with the demand that hits your server, they'll expand it for you and, of course, charge you accordingly. But the advantage is you don't have an idle server sitting around waiting for that growth to come. So that's a contrast between the platform as a service and traditional web hosting. Now, take a look at these two pictures here. Tell me which one of these is running a cloud and which one of these is just hosting traditional servers. If the answer is they're indistinguishable, that's because they are. It's because the same hardware is used for a cloud service area and a just web hosting environment. They're servers, they're plugged in, they have wires, they have air conditioning. And so all of the same requirements physically are there. The difference is the software that's being run. Now, the entire ability of a cloud to function depends on the ability of creating virtual desktops, virtual servers. And so if you've had any experience with VMware or the virtual box, you can see that you can run an operating system inside a window. That's a virtual machine. And so in this case, there are, looks like 3 different virtual machines running on a Macintosh. And when you do this, you notice there's a big performance problem. So you run Windows on a Mac and it kind of runs slow. Now, the 10% loss is what I've been told is what you actually get from a loss of CPU percentages and extra memory that's used. And so virtual servers have a penalty by interpreting the applications and the operating systems that they run on. However, we could say that there is this huge benefit of having multiple machines running on one piece of hardware. So if your requirements as a user were to have two different versions of Windows and a version of Linux running on your Macintosh, you'd have to buy 4 different computers. So obviously this is better as far as the utilization of the computer goes. And so the same thing happens in the server world. So if you have a server whose job is just to do one little thing once in a while, you don't need a very big virtual machine. And instead of sitting idle all the time, you can just provision the virtual machines that are there. Another huge benefit of virtual machines is the ability to manage them virtually. So you can see in this console, there are multiple machines that are all being run, and it's a simple matter of right-clicking sometimes to change it. If you want to move it, shut it down, copy it, make a duplicate mirror image somewhere else. And so virtual machines are as simple to use as programs on a computer. So a great way to compare a virtual machine to what you might know already is the ability of looking at your task manager. So here on the right, you can see there is a typical task manager for Windows. It shows you what programs are running, how much memory they use, and how often the CPU is called. And so very similar to that, you would have a program called a Hyper-V Manager. This is the Windows multiple virtual machine console. And so you can have a virtual machine listed as just another application. So you can see how much one computer is using over another. So here's some cautions. If you go and run this route, there are some problems that you may encounter. For instance, you start building your application on a proprietary service, such as Google Firebase. So Google Firebase is a NoSQL edition of a database, and it's really easy to start up and start using. It's like free to begin with, and then they just start charging you more and more as your user base grows. So one caution in regards to just business planning is that you might be stuck with a proprietary product here. So if you build your app to run only with Firebase, then that's what you're going to stick with, and you hope that Google keeps it running the way that they promised in the future. And so that is one caution. Another caution is that you probably won't save money. According to the analysis that I've heard and seen, is that you're going to save a lot of money on your capital costs. So you don't have to install servers, and you can actually lay off people. You don't have to hire them. And all you're doing, though, is really shifting your costs to somewhere else. So you're going to pay more on a monthly bill and less on an upfront cost. So the flexibility really is the benefit that you're getting. Now, there are some security concerns. So, just like you would with any server, you're going to have to ask these questions. And some of these make more grave decisions when it comes to the cloud. For instance, where is the data? So if you are working with, let's say, a European customer, they may require that your server be in Europe. Or if you're working with a Chinese customer, they probably have government issues with them. Who has access to your data? So, you just gave your stuff to Google or Amazon. Are they are they trustworthy? What are the regulatory requirements? If your server is in some other planet, somewhere else, then you're going to have to obey their laws. Do you have the right and the ability to audit what's being done on your service? What is the agreement to your SLA, your service level agreement, like as far as downtime and backups and things like that? What is the long-term viability of the provider? So those big three companies, Google, Microsoft, and Amazon, don't look like they're going out of business anytime soon, but there's questions with some of them, maybe the smaller ones. Do they have enough capital to keep going? Also, what happens in a security breach? Who's to blame? If your database is hacked, is it your fault? Is it their fault? And there's going to be problems when actually something goes wrong. And so a big part of cloud is the ability to have a better business recovery plan. So if your servers go down in California, then the ones that are in Texas probably will be able to pick up the slack. And so usually cloud concerns on being multiple sites is actually better. What's not new with cloud security? So you can still lose your data. You can still have downtime. You can still have phishing attacks. People can crack your passwords, and there's other malware around there. So there are all the same threats with your applications as before. Just moving them to the cloud is going to add some new ones. So you're going to have to think about security in more than one way. Here's some best practices and what you can do to make your virtual servers actually better than what you have right now. So think of the tasks that servers have to do. Now, in the past, if you set up, like for instance, a mail server just to do email, it might be idle most of the time. And so with a virtual system, you can now dedicate one virtual machine to each task. So you can have an email server, you can have a database server, your web server, maybe your security, your firewall. You can have a file server, your authentication server. Each one of these now can be dedicated to its own job. Now, that's really cool because in security-wise, you can lock down your machine so that only certain port numbers are accessible. So for instance, in a mail server, 587 is a common port number. And you would set it up so that only the email traffic can come into your server. There's no reason to have Telnet and web servers and FTP and all those other things opened up because that server has only one job. And so it's easier to manage if you only have one type of traffic that you can filter. And the firewall will tell everyone else just to go away. And so hackers would have a less easy time in finding open ports with your cloud service. Another good security best practice for cloud is that since you're on the cloud, you're on a global network. So you can duplicate your data. You can say that my application server is on the West Coast, East Coast, on a different continent. And so those things make your data fault tolerant. And you have to configure it, of course. And of course, they're going to charge you to have those extra different things. You can quickly restore service when things go bad. So for instance, if you have data corrupted in one place, you should have a backup that is like on a hot swap kind of a thing where you can just synchronize the data from another. So in the case of, let's say, ransomware, if you have a service that is completely locked up and encrypted by a hacker, hopefully you have a backup somewhere else that you can restore from quickly. And then you can just keep going on as business as usual. So that's a great indication of having a good setup so you can have redundancy. Now with cloud services, it's a great idea to make sure that your data is encrypted. Yeah, there is a performance hit when it comes to CPU and memory, but really if you're on a public area where people can get to your data, then why not just make it encrypted? It's worth the effort. Also think about using your logs in an off-site location. That's a good practice. If you have your logs on site and the same server that the hackers are at, they can just go into the logs and delete things so that you never know that they were there. So keep your logs somewhere else. Now following this, I'm going to have a tutorial that will show you how to do an application install on Microsoft Azure. And so you go through the configuration and see what the options are, and you'll have a real hands-on experience with becoming a publisher on a cloud platform. So thanks for watching. Check out some of the other videos with hacking and with security issues and programming. There's hundreds of things on the channel to look at. So I'm glad you're here, and thanks for watching.